Okay, so now let's move on to question number 5. So on a particular night, a waiter serves 100 people. For estimation purposes, assume a sample, that the sample means and standard deviations that you found in problem 1 represent the population mean and standard deviations. Okay, so these were the sample means and populations, but now they will be the population. Okay, we often have to do this in statistics because we don't have a population, we have a sample. So what do? We basically we hope that the sample is close enough to sample mean and standard deviation are close enough to the population that we then can use them to make inferences about the population. So the question says estimate the probability that the average tip percentage amongst the 100 people is more than 17%. Okay, so let me write this here. So now we're trying to find the probability that x bar is greater than 17. Okay, now we already found, so this here was the probability that x is greater than 17, right? And this was using we just counted, right? And that was nice because we actually had a sample, so we could actually just count empirically, how many people we observed had tipped more than 17%. This question is different in that we're asking about 100 people that we do not have a sample for, right? And we're asking on average how, what the average tip percentage is going to be, more than 17%. Okay, so not just for a particular sample. What's the chance that on a particular night it's going to be more than 17%? Though on average, if I serve 100 people, on average, if I keep on serving 100 people every night, how often will I have a tip that's more than 17%? Okay, or what's the probability? What's the probability that the tip will be more than 17%? Okay. So let's see here. I'm going to write this here. So now, we're going to assume that x bar is going to follow a normal distribution because we're going to use the central limit theorem, which says as long as the sample size is large, in this case, n in this case is 100. Okay, so if the sample size is large, it's okay for us to assume that the data follows a normal distribution, that x bar follows normal distribution. Okay, so what's the standard error for that normal distribution? It equals the standard deviation divided by the square root of n. Okay, so we're going to need that. We're also going to need, we're going to be using, so let's draw this out. We're trying to find the probability that we're greater than 17, right? So we're trying to find if this is 17 here, we're trying to find this area over here. Okay, so if we're using Excel to do this, we're going to be using the CDF, the cumulative distribution function, which doesn't find the area to the right, but it finds the area to the left. So we're going to need to use complement, and we'll say, okay, so therefore this is going to equal 1 minus the probability that x is less than 17. Okay, so we'll use this, we'll plug this into Excel, and we'll be able to get the probability that the mean is going to be more than 17. Sorry, this should say x bar, right? Okay, so I'm going to write this over here. I'm going to make this larger so you can see it. So problem 5. Alright, so I'm trying to find the probability that x, I'm going to write it as x slash bar, is greater than 17. Okay, so the average tip amongst 100 people, what's the probability that the average tip amongst 100 people is going to be more than 17? So this is going to be 1 minus that probability that the average tip is going to be less than 17. Alright? To find that, I'm going to use that norm dist, right? And x, right, that's going to be that 17. The mean, now it said to go ahead and use the mean from problem 1. So I can go over here, I can highlight this cell. I also could have just typed in 17.06, but I also just highlight the cell, and that works fine too. The standard deviation is going to be the standard deviation for all the people. But then, since this is for sample mean, this isn't for the data, right? We're not trying to find the probability that people, the probability that people tip more than 17%. No, what we're trying to find is the probability that, on average, the 100 people are tipping more than 17%. So we have to divide that by the square root of n, SQRT. That's the square root function. And we write square root of 100, not square root of 10. Square root of 100, which you could write it like this, or you could have just written 10, since you know the square root of 100 is 10. Either way, you'll get the same answer. Alright, and then cumulative, true. Right? For normal dist, we always say true for cumulative. So there we go. There's the probability that x bar is greater than 17. And then for part B, estimate the probability that the average tip percentage amongst 100 people is between 15 and 20. Alright, so now we just need to, we're going to use the same tools, from part A. We're just going to change it up a little bit. So now we're trying to find the probability. Oops. We're trying to find the probability that we're between 15 and, Control Z. That x bar is between 15 and 20. Alright, so this is, if here's 15 and here's 20. This is that we're trying to find this area in between. Okay? So I can use our trick where we say, okay, so this is the same thing as the probability x is less than 20, right? And if the probability x is less than 20, right, this probability here would be all of the area in this direction, right? Including the area that's less than the 15, right? It's all the area in this direction. So, we don't want this area less than 15, right? So I have to subtract that off in order to get the red area between 15 and 20, which is ultimately the goal. Okay? So, subtract off the probability that x bar is less than 15. Alright, so if I go over here, the probability that we're between 15, the x bar is between 15 and 20. So I'm going to use that norm dist. And then I'm going to start with the 20. The mean is, I'm going to go over here and grab it. And then the standard deviation, I'm going to go over here and just click on the cell. And then I'm going to divide that by 10. Remember, because this is trying to find the probability for the mean, not for the data. So square root of n, what in this case is 10. Cumulative is true. Okay, I'm going to subtract off norm dist, subtract off when it's less than 15. Alright, I'm going to go over here and grab the mean again. I'm going to go over here and grab the standard deviation divided by 10, and then write true. Alright, and there we go. There's the probability that the sample mean is between 15 and 20.